Hi guys, I'm going to talk to you today about the basic data structures. Uh, Now, some of this is review, but that can't hurt you either. All right, these are the data structures we'll be using in CSC 230 data structures class. Uh, okay, a record is basically of the data part of a class. So this is basically the data part of turn back up. LASS. And it is a structure that stores random pieces of data. Not so random, but data so class variables are otherwise known as fields. Now, an array is a data structure that has indexable and holds item, all of which has the same type. So arrays are indexable. That means you can put something in square brackets and get it an element of an array. So indexable. And all same. I'm going to leave out type. But now, that type might be something like object, which you can fit any other thing into. But you can also restrict exactly what goes into an array. So if you have an array of integers, you can only put integers into it. You guys know that. Okay. Now a linked list is uh, basically it stores items in nodes. I call them links because it's a linked list, but whatever. And each node stores data, has pointed to the next node, and there's all sorts of variations you learned in your previous class of linked lists, all of which basically do the same thing now. The linked lists have certain speed advantages and certain speed and space disadvantages over arrays. And we'll talk more about that in future classes. A binary tree, you've seen also, is there we have nodes that have to have 0, 1, or 2 children. 0, 1, 2 children. And sometimes we know that as the left or right child. I have trouble telling left and right apart, so I will tend to use various other names sometimes for the two children based on what it means to be one child or the other. Sometimes it doesn't matter, though, so then we refer to them as left and right childs. So, okay, now we get to the data structure stuff. So this stuff, the rest of these are stuff that's data structure. Oops, what's going on? There it is. These yellowed guys are data structures, stuff that's relevant to our class that you haven't seen already, probably, unless you're taking it for the second time or something. Okay, so a hash table stores a set. That is, the items it's not indexable. The items aren't in an order. They're just either in or out. And the best we can do is we have a way of referring to the items in the thing. They each have their own unique name type things. Okay, called a map or a hash. And we'll talk more about that later. A max heap maintains something called a priority queue, which means we can get at the biggest items still in the data structure. Okay, we use that to implement something that allows us to get the biggest item because that's always it's a kind of binary tree and it's always on the top. But the data structure we're interested in actually is called the priority queue. And a graph, we're not going to, is actually a little beyond what we're going to do. We're going to just touch on what a graph does. A graph is a fairly general data structure that can store data that's arbitrarily related to each other. So these are some of the most basic data structures. And the reason why is that we're not only interested is we build one of some of these out of others, and also we can recognize some of these data structures as important. Uh, as even things like linked lists, we're going to be studying things like how fast can we access the linked list? How much faster can we get at data if it's in a binary tree, and questions like that. So even the data structures you're familiar with, like arrays and linked lists, we can still get into issues about how fast and how much space they take up. And I think, and that is where I stop things.